then it's not degrees. So that one is not degrees. That one is radians. Okay, so I don't think naturally in radians. I imagine you don't either. So let's change it to degrees. You don't have to, but I think it might be nice. Does anybody know the conversion between radians and degrees? Did you know that pi radians equals how many degrees? 180 degrees, yeah. So what I do to convert, I know there's an official, you can multiply by whatever, but I can never remember that. I just always stick in for pi 180 degrees. I think that's the easiest thing. I just remember, like I said, that's why I didn't want to take that bio class. I have bad memory. I just remember one thing and then just work with that. So pi is 180. I just remember that, and I can work everything else out from there. So pi over 2 becomes 180 over 2 degrees, right? Pi radians is 180 degrees. And so that means this thing's 90, which probably a lot of you already knew. It's pi over 2 is 180 over 2 is 90 degrees. So what kind of angle is this one then? It's a right angle. It's 90 degrees. Good on that? So anytime you've got a pi radians, just put in its place, replace it with 180 degrees. You can also, you might be thinking, well, Mr. Aaron, we learned in this other class that you multiply by, see, I can never think of it. What would it be? 180 degrees over pi radians. Sure. Yeah, you're right. That's right. If you want to do that, cancel it out. Same answer in the end. That's okay, too. I just like to keep it simple. Pi is 180. Boom, that always works. Either way. Maybe I'll write what's the word. Find the radian measure of the central angle of a circle of radius 4 yards that intercepts an arc of length 10 yards. Okay, so angle, the radius is 4, the arc length is 10. I don't care about yards. I don't need to do anything with that, so I won't even write it down. So in other words, here's what they're saying. Let me draw a picture. They're saying, hey, we got some kind of angle, some kind of piece of a circle, little chunk of a circle. In fact, maybe it would help if I drew a whole circle. Maybe not. I don't know. Let me see. So let me draw a whole circle. And we have a central angle, and we're just saying, hey, we're just taking this little piece right here, and this little arc right here, this arc is 10. And the radius, what is the radius of a circle? From the middle to the edge, right? Halfway across. So that's 4. This is also 4. Either one, both, whatever. From the middle to the edge, anywhere, is 4, right? That's the radius. And the arc length, right? That's the arc length. That little piece of arc, that little piece of the circle is 10, they're telling me. And they're saying, hey, what's the angle? What's that angle there? What we usually for angles, you can just write angle. You can use x if you want. Usually we use theta. That's a Greek letter, but that's what might as well get you used to it. That's what we always use. Is that little? That's just simply a Greek symbol. Is all that is. I remember way back when I took physics back when I was just a high school student, and I remember I told you I did badly in high school. Here's one of the reasons I did badly in high school. I was weird. You guys know, what's the Pythagorean Theorem? You guys remember the Pythagorean Theorem? Yeah, a lot of you guys remember that. A squared plus b squared is c squared, right? We'll get to using that in a little bit. But I remember with the Pythagorean Theorem, when I was in high school physics, the teacher, Mr. Grimes, he wrote on the board, alpha, that's the Greek A, right? Alpha squared plus beta squared is gamma squared. That's the same thing, right? Those are just Greek letters. I was confused about that all year long. You know, high school's a year, right? And it's so dumb. I look back and go, Brett, why didn't you just walk up and ask him what that is? All year I kept going, what is that? That's weird, right? Because it was just Greek letters instead of English, but it was confusing for me. All right. Anyway, so I just want to let you know that theta is just a Greek letter. Nothing more fancy. It's all that is. So anyway, there's a formula for finding arc lengths related to angles. Anybody happen to know it? I'd be impressed if you did. Arc length, that's supposed to say arc, is r times theta. Usually they call it S. I don't know why they use S for arc length. S, the length of the arc, is r, radius, times theta, times angle. But, really important thing about this formula, theta must be radians. Can you read that down there? Radians, the doceri watermark's in the way there. Theta must be radians, not degrees. They could have made the formula in terms of degrees, but they just happened to make it in terms of radians. So, not degrees. So you want to really remember, that's the one thing that can mess you up on that. The arc length formula, how long an arc is the radius times the angle opening in radians. R times theta. So what then? Well, so let me go over here and say, okay, arc equals R times theta. There's my little formula. It's got three players. Got arc length, got radius, got theta, right? So what am I going to do then? Plug in, I've got arc length, 10. Radius, 4 theta. 10 equals 4 times theta. So I can solve for theta now. Does that make sense? How do you solve that little equation for theta? Divide by the 4. Use your calculator. What is that? 2.5? Theta is 2.5. That's the answer to the question. Oh, no, whoops. Look up here. They said integer. Yeah, the blue line will always tell you the format. They don't want a decimal. So they don't want, let me get rid of that 2.5. They don't want a decimal. See what they're saying there? They're saying, give me an integer or a fraction, no decimals. So they're being picky. On a test, I don't care. But so instead they want a fraction. So I'm going to reduce this, divide top and bottom by 2, be 5 halves. That's what they want. Same thing, but they happen to want a fraction instead of a decimal. If you're ever unsure, if you're looking and go, well, how do I, if you don't, the blue line will tell you. But if you happen to miss it, you can always click. Let me go back and I'll come back to it. Questions I can answer, there it is again, in case you didn't get it all copied down. Makes sense. So we just use S equals R theta, or arc length equals R theta. Plug in the arc length of 10, the R of 4, solve for theta. All right. So 70 degrees, change to radians. Oh, by the way, this answer I just got right here, this 5 halves, or 2.5, either one. I'll just say or 2.5. Is that radians or degrees? How do we know it's radians? There's no degree sign. And when you use the S equals R theta formula, it's automatically radians. For 2 reasons we know it's radians. Right? The arc formula, only radians. And there's no degree symbol. That's radians, isn't it? Notice, no pi. But it's still radians, isn't it? Because there's no degree symbol. All right, getting back to this. So 7 degrees change to radians. It's degrees, clearly. It's got the degree symbol. So it's degrees and want me to change it to radians. How do I change that to radians? Well, if you're taking chemistry yet, you know, that's where I learned to convert units was chemistry. The easy way, I could tell you it's going to be pi 180. You know, that's the conversion, right? Pi radians is 180 degrees, as I already said. But which way do you put it? I mean, is it times pi over 180 or 180 over pi? The easy way I learned in chemistry is just think about units canceling like anything else cancels. Meaning, I'm going to multiply by, I have degrees up here on the top, so I want degrees to go away, don't I? I'm trying to get to radians, so I don't want degrees anymore. So if degrees are in the top, you know, this is over 1, really, right? That's what I mean by top. Any whole number is really over 1, is really in the top, right? So if degrees is really in the top and you want it to go away, you got to put them on the bottom. So the 180 degrees must go on the bottom and the pi radians must go on the top. How did I know that? Because I want degrees to go bye-bye, to cross-cancel. Right? Remember fractions cross-cancel when you multiply? Top to bottom, diagonal. See how I knew which way to put that conversion fraction? So I didn't have to memorize something. See, I always try to avoid memory. So just think it out. Just think, hey, you got to get degrees to cancel, so they got to be in the bottom. Right? That's how you convert in chemistry as well. So what does that mean? So I got 70 pi over 180. That is an answer, but it's not reduced. What do they want? They want an exact answer in terms of pi. So I just got to reduce that. That's 7 pi over 18, right? It's divided by 10, top and bottom. There's my answer. Is that good? When they say exact answer in terms of pi, meaning they don't want you to put in 3.14 for pi. Because pi is not exactly 3.14, right? It actually goes on forever, and then you wouldn't be exact, and they want exact. So this is exact. put in decimals, the pi goes forever, so you're not exact anymore. Questions, we good? Now to number 6. It says convert to degrees. So you got pi over 3 radians, and you want to convert to degrees. So how could we convert that to degrees? Well, you can do the formal multiply thing if you want, but I think the easy thing is just to stick in the 180. Pi's 180, right? This is 180 over 3 degrees. So this is 60 degrees, done. Good? So notice I did not do the formal multiply by 180 over pi. You could. But when there's a pi sitting there, I just think put in the 180. Divide by 3, it's 60. 60 degrees. Good on that. So I'm going to keep moving. Okay, so 13 pi over 9. That's clearly radians because there's no degree symbol, right? It's radians. They want me to convert it to degrees. Go ahead. Try that one. Let me give you a second on that one. So you can do the formal if you want. I would just stick 180 in the place of pi. So 13 times 180 degrees. 180 degrees is what pi is, pi radians. So now, how do you do that? You can use your calculator if you want. I would go 9 goes into 18 2 times, right? So 20, because the zero's at the back. Am I going too fast? Right? So 9 goes into 8. Don't worry about the 0. When you have zeros at the back, just ignore them. Do the work, do the math without the zeros, and then put them back on when you're done. Right? 9 goes into 18 2 times, right? And then throw the 0 back on, so it's 20. And then, so the 9 is gone, the 180 is gone. 9 went into 180 20 times. Now, what's left? 13 times 20. You don't need a calculator for that. Let's cover up the 0. What's 2 times 13? 26. Throw the 0 back on there. 216. And it is degrees. We do have a degree symbol. Now, there we go. Right? Good on that? All right, stop me if you want to talk about it. Okay, so there you go, 97 degrees. They want me to convert to radians. And they want, notice they say round to 2 decimals. So this time use your calculator. They want you to actually put in the 3.14, maybe even more. If you have a pi button, that would be even more useful because it's got a whole bunch more decimal accuracy. 3.14 might be enough, I don't know. So multiply by, so do the right conversion. You want to get rid of degrees, right? So you got to put degrees down below. Right? You want to get rid of degrees. You want to cross cancel degrees. So this is over 1, so put degrees on the bottom. You with me? You want to be motivated by what you're trying to cancel. Trying to get rid of degrees. Everybody seeing what I'm saying there? So I'm going to put the 180 degrees in the bottom of the pi. It's always pi and 180, one way or the other, isn't it? Because that's the conversion. Pi radians is 180 degrees. I know I got to put degrees in the bottom to get them to cancel. Okay, so it's 97 pi over 180. The degrees are gone, right? Look at those little zeros are canceled out. The degree symbols are canceled out. So that's the answer, except they want a decimal. So if you put in 3.14, that might not be enough accuracy. I don't know. Let me try it on my own calculator here. 97 times 3.14 divided by 180. I'm getting 1.69. Well, 692, but they want 2 places, so it's just 1.69. Is that what you all are getting? Anybody use the pi button? Is it different? Is it comes out good enough? Yeah. So if you have a pi button, it doesn't make any difference. Sometimes you might want to use the pi button if they want more accuracy. You know, there's a pi button that'll give you more decimal places, right? Pi really goes forever. Good on that. I'm tempted to talk about where pi comes from and why it goes forever and what is pi, but we don't have time for that. Wait through the homework some other day. Actual angles. So we've got the angle 4 pi over 3. Let's start there. So 4 pi over 3. You want me to say which one of those pictures is 4 pi over 3? And what I would do first, because I don't naturally think that well in radians. It's in radians right now, right? There's no degree symbol here. That's radians. So is I'd convert it to degrees. You don't have to. If you just naturally can think radians, great. That's fine. I don't do that as well. So I'm just going to convert to degrees like that. So in the place of pi, like always, I put in 180. Right? And you can do this without a calculator. Right? How would we do that without a calculator? 3 goes into 18. 6 times, put the 0 on the back. And then, so these are gone. These are gone. They're not there anymore. So what do we have? We have 4 times 60 degrees. And 4 times 6, just do 4 times 6. 24, put the 0 on the back. So it's 240 degrees. I've converted 4 pi over 3 radians to 240 degrees. I think better in degrees. So yeah, what's 240? Well, let me draw a coordinate system up here. All those words are in the way. So all right, it's good enough. So where do we start? Well, by simple convention, no logical reason, we just start right here. That's 0 degrees. They just agreed. There's no reason. They just said, hey, straight to the right, positive x-axis, that'll be 0 degrees, and we'll open up from there. So starting right here, we're going to open up 240 degrees. So if you're at the positive x-axis and you start opening up the angle, right? If you go straight up, that's 90. Keep going, that's 180, right? If I'm right here, that's 90, right? That opening would be 90. I'm opening this way. So keep going. This is 180. Even for if you go all the way to here, that's 270. It's another 90, huh? 3 90s is 270. That's too far. 240 is supposed to be 180 there. 240 is somewhere in this zone, isn't it? So 240 would be about there. So our angle of opening goes from here to there. And it's 240 degrees. So it looks like it's what? Which was it, A, B, C, or D? Yeah, it looks like it's answer C here. Does that make sense on that? So we started from 0 degrees and opened up to 270. Third quadrant, right? Remember how the quadrants go? Quadrant 1, quadrant 2, quadrant 3, quadrant 4. They start in the upper right-hand corner and they go counterclockwise for I have no idea why. Those are things they just made up by common agreement. So there we go. No questions? Is that good? Down instead of going up for a negative angle. So this one is negative 5 pi over 3. So let me do this one quick. So put in the 180 again in the place of pi. So what is it going to do from there? It's 3 goes into 180. 60 times 5 times 60. It's minus 300 degrees. So I converted it to degrees. It's minus 300 degrees. Okay. So how does that mean? You see, this is 0. Whoops. Shaky line there. Straight to the right is 0 degrees. We're going to go negative. So we're going to start by going down 300 degrees. So if I go down, that'd be negative 90. Now you might think, wait a minute, you said that was 270 a minute ago. Right, they're the same thing. You can call that positive 270, straight down, positive 270, or negative 90. It's the same location. 2 ways to get there. There's actually other ways also. This would be negative 180. I keep skipping that 0. Negative 180. This would be negative 270. We're going even a little further, about right there. So from here, from right here to there is negative 300 degrees. So which answer is it? It's C again. Isn't it? Does that make sense on that? That good? So negative just starts by going down instead of up. Okay, so here we go. So 520 degrees change to something less than 360. So in other words, 520 is more than one time all the way around, isn't it? Right? Whenever they give you angles more than 360, basically there's a simpler way to say that angle, isn't there? So if we start right here, which is where we always start, 0, and we go all the way around, that's 360. And 520 keeps on going. It's more than all the way around. Well, how much more? We'll just subtract the 360, right? What is that? Is it 160 or 520? I think that's right? So 160. So that means, what does that mean? That means you go all the way around 360 degrees and keep going another 160. You with me? Where's that? Well, this is 90. This is 180. So another 160 would go somewhere almost to there. Huh? Does that make sense? Where I ended up? So we start here at 0 to the right, where we always start. And you go all the way around 360 and 160 more. That's 520. So really, 520 is the same as just doing 160, isn't it? 520 is the same location as 160. See, I turned around 520 degrees. Well, that extra turn was wasted. You could have just turned 160. That's what we're saying. Does that make sense? That's all they want. So the answer is 160. That's the answer they want. So when they say the word coterminal, that's a fancy word. Co means with, right? Terminal, ending in the same place. So that means same ending. Coterminal. So negative 980 degrees. How do you do that? Well, you go down and around 3. There's negative 360. I went down 360. Do another 360. That's down 720. I did 2 360s, and I'm still going. So I take my 980. Whoops, I keep skipping that last 0. Take my 9. I know it's negative 980, but let me just deal with plain 980. Subtract a full. You just keep subtracting full circles. Just use the positive version to start with. I know it's negative. We can straighten all that out in a minute. Let's just keep subtracting full circles until you get something less than a full circle. So if you subtract 720, 360 twice. You know, if you wonder, where'd you get 720? That's 360 twice. So you don't need to write 720. If that's confusing you, pretend it never happened. Just subtract 360 twice. That's 720. That's all I'm doing. So subtract 3. Why? How do you know? Well, if you subtract 360 the first time, maybe I should take it a little more slowly. If you subtract 360 the first time, you get 620, and you go, oh, that's still more than a full circle. So you subtract 360 again. What is that? 260? And you go, oh, okay, there it is. 260. But remember, it's actually negative. I just wanted to ignore the negative sign to make the math easier. It's actually negative 260. You good so far? I've got to change that to a positive angle. But everybody good so far? I'm saying 980 degrees, positive or negative, whatever, doesn't matter. Subtract 2 full circles. Okay, I finally have an answer less than 360. But remember, it's really negative 260. So how do you say negative 260? That's the same as what positive angle? Well, you just add 360. It's the same as 100 degrees. Let me show you why. Negative 260 is going to go this way, isn't it? And it's going to go almost to negative 270. Right? It's right there. Everybody see that? That's negative 260 degrees, which is the same as their original negative 980. I just took out 2 full circles, took out 2 360s. So negative, well, how do you, negative 260 is the same as what positive answer? They want a positive answer. Well, then you just say, here's the positive answer. What is that? 100. Yeah, because it's all the way around 360 take away the 260. So you just take 360. You're right, you're just taking it away from a full circle. It leaves 100 degrees. Is that making sense what I did there? Am I confusing you by that? Right, because I'm just trying to find this part that's left. Maybe I could say it this way to be more clear. I'm just trying to find this part's left. This must be 100. How do you know? Because this is 260. And all the way around is 360. Isn't it? You tracking with me? So if I said, hey, all the way around is 360, and I just went 260s, how much more do I have to go? Subtract. Right? Does that make sense? So that's why I subtracted 360s all the way around. I'd already done 260. How much was left to go? 100. That means this part must be 100. Positive 100. So negative 260 is the same as positive 100, isn't it? And negative 980 is the same as positive 100. So the answer is positive 100. All right. Radians, don't they? Okay, so they're saying the coterminal thing again. That just means with endings. Ending in the same spot, right? Same angle. So 29 pi over 4. I don't know what you want. I never care how you do a problem. It's whatever way is easiest for you. You could just convert it to degrees, do the entire problem in degrees, and then go back to radians if you want. That'd be fine. Maybe I'll do that. So I'll convert to degrees. In the end, you got to go back to radians, though. So maybe I'll show both ways. So I'm just going to put in degrees first. 180 degrees over 4. Just hit the buttons on your calculator. That's a big one. I'm not going to try to do it by hand.
I have a question.
Question.
Are you going to allow us to use like a cheat sheet for our test? No card or something?
Probably. I'll give it some thought. Probably. 1305 degrees. Over 4, yeah. 1305 degrees. So what is that? Well, it's a bunch of full circles, right? So subtract 360 a couple times. Subtract 360. What do you get? 945. Subtract 360. 585. Subtract 360. What's that? 225. Okay, so I finally got an angle under 360, 225 degrees. You guys with me? I just put in 180 for the pi. Got the 1305, took out a bunch of full circles, 225 degrees. So now, 225 degrees, let's convert it back to radians. That's what they want. They want something less than 2 pi. What is 2 pi? What is 2 pi? That's all the way around. That's 360, isn't it? Remember, because pi is 180? So 2 times pi, 2 times 180 is 360. So they're basically saying the same thing. Just give me an answer less than all the way around. So now we got to convert that 225 back to radians. How do you convert to radians? Put degrees in the bottom so that degrees will go away. Radians at the top. So it's 225 pi over 180. That's the answer, except it needs to be reduced. Am I going too quick? See what I did there? I got my 225 angle. Converting it back to radians now. Divide top and bottom by 5. What is that? I don't know. 24, 40, and 4. Is it 45? Okay. Pi over 36? Oh, I can reduce that even further, can't I? Divide by 9. That would be 5 pi over 4. There's our answer. Is that okay? Did you track with all that? Everybody see what I did? Want me to run over that one more time? So I took what they gave me, 29 pi over 4, put in the 180 for pi, got this big old angle, took out some 360s till I got an answer below 360, 225, converted it back into radians because they want the final answer in radians. So the degrees have to cancel, so put the 180 degrees in the bottom. Got this 225 pi over 180 and just started reducing the fraction. I knew 5 went in because it ends with 5s and zeros, so 5 goes in. Then 9 went in, 5 pi over 4. Now you could go direct. You don't have to do it the way I did it. Yeah?
How is it less than 2 pi?
So 5/4 is 1 1/4.
Oh.
So that's less than 2. Yeah, good question. Yeah, everybody see? 5/4 is 1 and a fourth. If you made it a mixed number. We're not going to make it a mixed number. But everybody see that is less than 2. That's 1.25. If you did a decimal 5 divided by 4, that's 1.25 pi. That is less than 2 pi. We have done what they wanted. Yeah, the other way, I'll say or what you could do is just take 29 pi over 4 and just start subtracting a bunch of 2 pi's, right? Because that's full circle. So I'm subtracting 3/60s, but I'm doing it in radians. This is the other option. You don't have to do it this way. But if you're comfortable and you want another way that'd be a little quicker technically, is you subtract a bunch of 2 pi's, right? Because that's like subtracting 360, except it's in radians, right? Well, how do you subtract 2 pi? Well, you know how to do fractions. You love fractions, right? How do you subtract 2 pi? You make it 8 pi over 4. That's a fancy 2 pi, and now it has a common denominator. Is that too quick? Right? That's 2 pi. 4 goes in 8 2 times. That's 2 pi with a common denominator, right? And so those are 2 pi's. So you subtract 8 pi over 4, subtract 8 pi over 4, that's 16. What does that leave you with? 16, 13 pi over, oh, we got to do one more, huh? Minus another, 3 of them. Oh yeah, I forgot we did 360, so 3. Another one, and see how you get straight to 5 pi over 4? Boom, done. So it is quicker if you're comfortable with all that. Get you right to the 5 pi over 4. Either way, it's 5 pi over 4. All right. So here's number 19. They're saying what? They're saying radius is 18, angle theta is 230 degrees. Find S, which is arc length. So find S, which is arc length. Okay, what's the formula? Remember? So probably what I'll give you for each exam is a 3x5 card to write little formulas on both sides of it. Probably. Let me see how the homework goes if we need that kind of stuff. So what is it? It's S equals R theta. Yeah, so give it a try. Let me give you a second to give it a try. Hey, feel free if you want to bring in your laptops. I am fine with that. Bring those in. Are you able to get on with the Wi-Fi, right? Yeah, so with the Wi-Fi, get on, because there's no data in here. It's kind of blocked. Well, it depends on your thing, but my little T-Mobile is all blocked in here. But you get on Wi-Fi, and if you want to do your homework, that's because I know for some of you this is like easy and simple and review, and you just want to get your homework done while I'm doing it. Great. Use your time well. So feel free. Some people will have their laptop with them. They'll look at what I do, and then they'll do the one on their own thing that's the same thing, different numbers, you know. They'll kind of get their homework half done here in these 2 hours. Great. Some people think, no, I don't want to mess with that. I just need to focus in. Then great. You know, whatever works for you. But it's fine. Or your phone. You can get on your phone and do the little Math Excel homework as we're going. You know, and once you have an account, feel free to bring that in and get some of that done during class if you can do that. All right, so how do I do this? S equals R theta. So just take the R times the theta. That's why I gave you time. I want to make sure you don't do that. Why? What's wrong? What am I doing wrong? Yeah, remember this is so I really wanted to help you remember because this is so easy to forget. The S equals R theta formula is only for radians. So we have to convert that degree to radian first. Even though they're not saying it anywhere, we have to just know it. That S equals R theta formula is only radians. So this formula is only radian. So you really have to remember that. It's not going to jump out at you. You got to intentionally remember that. It's only radians. So what does that mean? You got to convert 230 degrees to radians, then use the formula. So you know how to do that. Just put the 180 degrees at the bottom, so degrees cancel out. Pi in the top. So it's 230 pi over 180. Reduce it, divide by 10, top and bottom. 23 pi over 18. That good? Just divided by 10 top bottom. Now use the formula. Now S equals R theta. S equals R, what's R? 18 times theta. 23 pi over. That is so convenient. That's very nice of them. Right? Because then those 18s just cross cancel, huh? Everybody see what I'm doing? The R is 18. And the theta, as we just converted it to radians, is 23 pi over 18. R theta. So the 18 over 1, those 18s cancel, don't they? So the answer is 23 pi. There we go. And they want us to leave it that way. See up here they say, type your answer in terms of pi. So we're done. I'm not going to put in 3.14. I'm going to leave it 23 pi. Everybody see what we did there? S equals R theta, but I had to convert the theta to radians. That's what they're mainly testing. Do you remember that you can't use degrees for that formula?
What if you were to do convert to radians after? Would you get the same answer?
Good question. Yeah, I think you could. I think you could do after. Yeah. Yeah, that would work. Before or after. Okay, so they're giving me R is 8. This is going to be very similar. R is 8. Angle's 120. But angle theta is 120. But they want area this time. So I haven't given you that formula. Area, so that means like if you have a piece of a circle, what's the area? Not just the arc length, not just the edge, but the whole piece of pie. How much area is the whole piece of pie? The area of a sector is 1/2 r squared theta. So it's a different formula. So this is area of a sector versus we had arc length. Arc length was S equals R theta. Area of a sector is 1/2 r squared theta. Again, only radians. Both these formulas, only radians. So what's the first thing I have to do then, because they gave me 120 degrees? I got to convert that thing to radians, don't I? Y'all with me? So first, convert 120 degrees to radians. So you take the 120 degrees and you convert it to radians. So you know how to do that. 180 degrees in the bottom, pi radians on the top. That's 120 pi over 180, which is 12 pi over 18, which is divide by 6. Two pi over 3. So far so good, we're not done? Yeah.
When it comes to these, like on a test, are you ever going to look for how we do things? Because can we use the reference angle as well when we convert from degrees? Would that still be correct no matter what?
Use the reference angle? No, not in a problem like this. Not for areas of circles. Yeah, good question. We'll get to reference angles, and we'll use them for trig functions. They work for sine, cosine, tangent, all that. But not for area, because you see, a reference angle would be less than 90. So you see what I mean? Like, how could an angle less than 90 have the same area as a bigger sector that's more than 90? Does that make sense? See how the reference angles wouldn't work for this kind of problem? Good question. Very good question. So 2 pi over 3. So we converted to 2 pi over 3. That's the radians. Now, come over here, and let's finish the problem now. So the area of the sector is 1/2 r squared theta. And so it's 1/2. What is the radius? 8. And then the theta is 2 pi over 3. Everybody good there? So then that's 1/2. Use your calculator. 8 squared 64 times 2 pi over 3. Can you all see what I'm doing there? I'm going to cross cancel these 2's. You can do that. You know, you can go far away like that. You can cross cancel anything on the top with anything on the bottom. And so what are we left with? 64, whoops. 64 Do they want a decimal? What do they want? Oh, yeah, that's right. They want that first, and then they want a decimal secondly. I'm just going to leave it here. You could use your calculator and turn that into a decimal easily, I know. Is that good? Does everybody see what I did there? So I took the 120, converted it to radians, because both these formulas, area of a sector and arc length, both are radians only. So this formula for area is a half r squared theta. And so I had to convert to 120, put the 180 degrees in the bottom, pi on the top, got 120 over 180 pi, reduce it, get rid of the zeros, divide by 6, 2 pi over 3. Then I plugged into the formula, 1/2 r squared theta, 1/2 8 squared, they gave me the radius is 8, theta, 2 pi over 3. That's 64, these 2's cross canceled, so 64 pi over 3. And then you would just put in 3.14 and give a decimal for the second part there. Questions on that? So area of a sector. If there was time, I'd like to show you where those formulas come from. Okay, I don't know if you can read all those little words. Basically what they're saying, it's fancy talk, find that angle. Find what hits right there. That's what they're saying. What is that angle? And they want me to do it two ways, positive and negative. Yeah, they want me to say, what's the positive version of that? What's the negative version of that? That's what they're asking. Well, can you tell that that's right in the middle? See how that's right in the middle of the first quadrant? So you know from here to straight up would be 90, right? Straight up would be 90. So what's halfway?
45.
That's got to be 45 degrees, doesn't it? That's the positive answer, right? In other words, from let me redraw it over here. So from here at 0 to here, from there to there, that opening, this opening right here is 45 degrees. They want me to say it also by saying, well, how far would it be if you started here and went that way? That'd be a negative angle, right? You with me? They want me to give both the positive version, because there's two ways to say that angle. There's actually lots of ways. You could do a full circle and then 45 also, couldn't you? There's lots of ways to say that same ending location, coterminal, ending with it, right? So there's a positive 45 degrees to be halfway in the first quadrant, or there's some negative amount. Well, how do I find out what the negative angle is? Subtract from 360, right? Because can you see that the blue and the little purple make a whole circle together? Do you see that? So therefore, just take 360, take the whole circle, back up 45. Right? Together, right? Take the whole 360, subtract 45. What is that? 315? But it's negative. So it's positive 45 or negative 315. Those are the same location. Everybody see how I'm doing that? Positive 45 or negative 315 are the same location. Why did I subtract from 360? Because again, the blue and the purple together make a full 360, don't they? Right? So the blue is the leftover when you take 360 minus 45. It's the rest of the circle left over. 315. And it's negative though. It's negative. So negative 315 is the same as positive 45. And they're both ending in the middle of that first quadrant. Good? Yeah.
And it says in terms of pi.
Oh, do they want pi stuff? I think you're right, huh? What did it say? Oh, yeah, I got to make those into pies now. Thank you, thank you. So, yeah, let's do that. So I've got to take the positive 45 now. Here, let me create some room. So, yeah, I didn't even notice that. So now, I'm always working in degrees. So now we got to take that positive 45 and convert it to radians, huh? So 180 degrees, pi radians on the top. So that would be 45 pi over 180. Reduce it. 45 goes in there 4 times, I think, right? Yeah. So it's pi over, just use your calculator. It's pi over 4. So I just converted positive 45 degrees to radians, like we've been doing a couple times. Got the degrees to cancel. Degrees canceled. 45 over 1, so 45 pi over 180, and then I just divided on my calculator. 180 divided by 45 is 4 times. So pi over 4 is the positive answer. Now what about the negative 315 degrees? Same thing. Times pi over 180 degrees. And so we get negative 315 pi over 180. And then I got to reduce it, huh? Divide top and bottom by 5. I don't know. What's 315 divided by 5? Somebody got that? 63. Thank you. Over, what's that, 36? Well, and then we can divide by 9, I think, right? Divide by 9. So negative 7 pi over 4. There we go. So we converted them both to radians, to pi answers. Good there? Questions on that? More real life applied. Let's see. Okay, so say you've got a clock and it moves through 5 minutes and 50 seconds. And they're talking about the second hand. The second hand on a clock. So if a second hand on a clock moves through 5 minutes and 50 seconds, they want me to say, how many radians is that? So the second hand, what is the second hand? It's marking off the seconds. 1 second, 2 seconds, 3 seconds. Well, that was kind of far, but right, you know what I mean? There's just seconds. It's counting off the seconds, right? So the second hand, not the minute hand, it's the second hand. Like the red one up there on our clock on the wall there, right? That's ticking off the seconds. So every minute, the second hand goes all the way around, right? 1 minute is all the way around. So 5 minutes means 5 times all the way around, first off, doesn't it? Right? So that 5 minutes is 5 times 360. Plus, and then we got to do something about the 50 seconds. You agree so far? 5 minutes for the second hand is 5 360s. Now what about the 50 seconds? What portion of a whole circle is 50 seconds? 50 60ths. Of means times, a whole circle. There we go. Is that too quick? Everybody see what I did there? So the 5 minutes is 5 full circles. And 50 seconds, right? Picture a clock, right? If it's starting straight up and it ticks off 50 seconds, it went 50 out of 60 seconds would be all the way around. It went 50 60ths, or 5/6, of all the way around another loop, didn't it? It went 50 60ths of always means time and times in math. 50 60ths of another full circle, another 360. Does that make sense? So 5 full circles and 50 60ths of times another full circle. Right? So now that's all degrees. Got to get that number and then convert it all back to radians because they want the answer in radians. So what would that be? What's 5 times 360? Something big. 151. Is it 1800? 1800. Plus, what's 5 60s? It'd be a 300. I think. Add that up. 2100 degrees. Got to convert that now to radians. So it's 2100 degrees. That second hand went through 2100 degrees. So now convert that. So I'll just come up here where I've got some room. Convert that 2100 degrees times 180 degrees pi radians. It's 2100 pi over 180. Cut off the zeros. 210 over 18 pi. Divide by 3. Top and bottom, what's that? 70 over 6 pi. That's what they want. 70 over 6 pi. That's how many radians the second hand moved through in those minutes. Is that good? Is that making sense? I don't think I'm going to make it. This is the story of my life, is time management. I don't think I'm going to make it. I'm at number 23 out of 27. We got 4 left to go. Okay, so what I'll do is I'll give a little more time. This homework is not going to be due till next Monday, so it's good. I guess I'll give you a little bit of time. So we got a week, so you've got a little bit of time to get on Math Excel. You do have to get on that. I will be looking next Monday and dropping people who are not on Math Excel. It's absolute requirement of the course. It's the cheapest deal you're going to get on campus, probably $60.50 for the entire course. Absolutely required. So you can jump on that homework though.